Okay, so 6.3 is about graphing to solve systems of linear inequalities. And I'm not going to read this section out to you because it's actually not going to be that helpful until we graph a few things. You may want to refer back to these notes because they're sort of the details about what I'm doing, but I think for this example it would be better just to get to the first example, okay? So the first example says graph the solution set for the following system of inequalities and then state two possible solutions from the set, and then of course it says check your work. All right, so my first equations are 2x plus y, pen here, 2x plus y is greater than 6, and then it says x and y are whole numbers. So remember what that means. Whole numbers start at 0, go to 1, 2, 3, on and on. Okay, so no decimals, no fractions, no negatives. My second equation is y is less than or equal to 3, and again, x and y are whole numbers. So keep that in mind. All right, so we need to create our boundary lines. Oops, keep writing, please. Okay, there we go. And remember how you do that. You just take your equation and you make it, or you take your inequality, sorry, and you make it into an equation. Y equals 3. Okay, so that one, 2x plus y equals 6. This one, y equals 3. We want to isolate y, so this 2x gets subtracted from both sides. So I have negative 2x plus 6, and this one is isolated. So those are my two equations that I'm going to transfer to my next page just so I can use them. All right, I'm going to just paste them here. So my two equations are y equals negative 2x plus 6 and y equals 3. Okay, so my first one, y equals negative 2x plus 6. Remember, in the form of y equals mx plus b. Here's my slope. Right here's my slope, and this is my y-intercept, meaning I start at 6. Okay, so there is my y-intercept. My slope is negative 2, so I go down 2 over 1, down 2 over 1, down 2 over 1. Now notice I'm in the first quadrant. Why am I in the first quadrant? Because my x and y can only be positive whole numbers. My other equation is y is 3. That means go to where y is 3 and you are going to have a horizontal line where y is 3 because it cuts the y-axis at 3. So I've already gone ahead and made lines that I can show you now. There is that one. Okay. Ooh, it's dashed. How come this line y equals negative 2x plus 6? Why is it dashed? Because my original question was a greater than. Okay. So dashed line here, solid line here because it's less than or equal to. Oops, going the wrong way. So there's my lines again. Okay, so I've got 4 zones. I've got this zone, this one, and this one. And I got to figure out, okay, where is my answer? So the easiest thing, remember, is to check an ordered pair and see what happens when you plug it in. I really need my original equations again so I could check. Remember, my original equations were 2x plus y was greater than 6, dashed line, and y less than or equal to 3. Okay, so I got to pick a zone, okay? And you know what? Y has to be less than or equal to 3. So I'm not even going to bother up here because I already know that this zone won't work because in this zone, y is greater than 3, okay? And 3 is as big as it can be. So I'm going to eliminate that zone as well, just so I don't have to try an ordered pair and have it not work. So I will try 1 and 1. This is the ordered pair I'm going to try into my equations. So I'm testing 1 and 1. So if I plug in a 1 here, I'm going to have 2 times 1 is 2. If I plug in y, which is 1, I'm going to have 3. No, I'm going to have 1, sorry, because it's 1. I was thinking 2 plus 1 is 3. All right, I have 2 plus 1 is 3. I have 3 greater than 6. 3 is not greater than 6, therefore this zone doesn't work either. My solution set is here. Okay, so I'm shading it so that you can see it. However, I hope you're thinking, wait a minute, you said that my solution can only be whole numbers. Remember, x and y were in the set of whole numbers. So actually, I can't shade this section because, remember, shading would indicate that it's everywhere in this solution, in this section, and I can't. So I'm going to get rid of that, and I have to stipple this time because remember, only whole numbers will work because it has to be whole numbers. Okay, so I'm going to put dots there. Okay, can I put dots on the x-axis? Well, yeah, I can. I can put dots here, but let's think about this. Can I put a dot right there? Remember, this line is dashed, so that line means it doesn't include it. So I'm going to put an open circle there because it can't include it. I can put a solid line there because this red line can include it, and I can include anything on that red line because that was a less than or equal to. So my solution region is stippled. This I couldn't use, so I'm going to put an open circle because this dashed line means it had to have been greater than, and that's not because it's dashed. Okay, so my solution set is the stippled region. And if it were a test, you should probably pick one of the ordered points in your stippled region. I'm just randomly picking that one and test it. Okay, so that's 6 and 1. So if I tested it up here, I'd have 2 times 6 is 12, plus 1 is 13. 13 is bigger than 6. That works. Second one, y has to be less than or equal to 3. Y is 1. 1 is less than or equal to 3. So I make sure that an answer in my solution region works. So the question did say, hold on, it won't go back. Get my mouse. It did say state 2 possible solutions from the set. So you can pick anything. Every time I get off this page, you can pick anything in here. So 6 and 1 would work, 7 and 1 would work, 6 and 0 would work. Any of the dots would work. Okay, moving on to example number 2. It says to raise funds to buy new instruments, the band committee has 500 t-shirts to sell. The t-shirts come in red or blue, and based on sales of the same t-shirts at a fundraiser 5 years ago, the committee expects to sell at least twice as many blue as red t-shirts. Okay, so it says first of all to define the variables and restrictions and write a system of inequalities that models the situation. So we have to assign x and y. So let's say that x is blue. I could have done it the other way around, that's fine. If x is blue, then y is red. Okay, so that's the defining the variable part. All right, restrictions. Well, we're talking about t-shirts, so they certainly can't be negative. And because they're actual objects, they can't be parts. You can't buy or manufacture part of a shirt or a decimal. So we're going to say that x and y need to be in the set of whole numbers. Okay, so define the variables and restrictions. That's done. Now it says write a system of inequalities that models the situation. So remember, x stands for blue t-shirts and y stands for red t-shirts. And they said that the band committee has 500 t-shirts to sell. Okay, so my first equation is going to be x plus y, the number of t-shirts. It didn't say equals 500. They didn't say they're going to sell 500. They said they have 500 to sell. Okay, so 500 is the most they can sell, but they might sell less. So my first inequality is going to be x plus y is less than or equal to 500, because it could be 500, but it might be less. Okay, so that's my first one. Now, the second one says, based on sales of the same t-shirts at a fundraiser 5 years ago, the committee expects to sell at least twice as many blue as red. Now, these ones can get a little tricky, okay? So, I'm going to show you something here. Blue, which is x, y, which is red. They said The committee expects to sell at least twice as many blue as red. So if I sell 1 red, they expect to sell 2 blue. If I sell 10 red, they expect to sell 20 blue. Okay, the committee expects to sell at least twice as many blue than red. All right, so how can I make this into an equation? At least as many blue as red. So if I say x is going to be greater or equal to 2y, that's how I'm going to model that I'm going to sell at least twice as many blue as red. Okay, so let's take a look at what I did over here. I said if red was 1, blue would be 2. Okay, y is 1. So if I plug a 1 in here, okay, if I plug in a 1, I'd have 2 times 1, which is less than or equal to 2. If I plug in a 10, I'm going to have 2 times 10 is 20, which is less than or equal to 20. So even though x is the one that's double, you have to put the 2 on the red because that's the way that you're going to get them to equal each other, or at least come close to each other in the inequality. I know that's a little confusing, and I've struggled with that as well, but I found that making these little tables helped me keep it straight. Okay? So my 2 equations that I have to graph in B, because it says graph the system of inequalities, is x plus y less than or equal to 500. I'm going to copy this. And y greater or equal to 2y. Okay. So the first equation I'm going to graph is x plus y is less than or equal to 500. Well, this one I could put into y equals mx plus b form. Down here. So if I leave y where it is, and remember if I'm going to do a boundary line, I'm going to just change that to equals. So I'm going to put the x to the other side, and then plus 500. The second one, I'm going to divide both sides by 2. So I have 1/2 x equals y. All right, so let's graph y equals negative x plus 500. Remember, y equals mx plus b. B is where I start. So I'm going to start on the y-axis at 500. My slope is negative 1 over 1. So down 1 over 1, down 1 over 1. Which makes sense, right? Because if I sell 500 of these, I'm going to sell 0 of those. If I sell 300 of these, I have to sell 200. If I sell 200, the other one has to be 300, etc. Okay? Now, what kind of line? Needs to be a solid line because that is a less than or equal to. So there's my first line. I'm going to adjust it just a tiny bit up here. There we go. Okay, my second equation. Y equals 1/2 x. Now, if you want, and it makes you feel better, put it that way. So it looks like y equals mx. There's no plus b, so that means that it starts here at the origin. Slope is 1 over 2, 1 over 2, 1 over 2. Okay? What kind of line? Again, a solid line. Okay. So we need to see where our answer is. We need to check zones. Use your common sense. Remember, I can't have more than 500 shirts. So this is no good and this is no good. This is where I'm more than 500 shirts. This is where I'm less than 500 shirts. So I'm not even going to test those 2 zones. I'm going to test this number. Okay, I could have tested this one or that one or that one, but I have to pick something, so I'm going to test the ordered pair of 300 and 100. I'm going to test that ordered pair into my equations, and if it works, here's my solution. If it doesn't work, my solution's over here. Okay, so when I plug my numbers in, remember x is 300 and y is 100. 300 plus 100, which is 400, has to be less than or equal to 500. Okay, that works. Now I have to have x has to be greater or equal to 2y. X, which is 300, has to be greater or equal to 2y, which is true as well because 300 is greater or equal to 200. So my solution is here. Now, these are whole numbers, right? We're talking about t-shirts, but My graph is not going by ones. My graph is going by hundreds. So I can pick anything that's in the shaded region. Like I could stipple it, but right now my answer looks like it's barely anything. Looks like not, it looks like this one here. That one would work, that one would work, that one, that one, that one. But they're not just selling hundreds of t-shirts, right? You can have one and 499, that's okay. So I'm going to shade it just to indicate that there's lots of different answers in here other than just the stippled parts. But keep in mind, like, you could have one, right? You could have two in this section. So it does say suggest a combination of t-shirt sales that could be made. So remember that X is blue, Y was red. So you could say 100 blue, right here, this ordered pair. I'm suggesting it. And 0 red. I could say this ordered pair, which is 300 blue and 100 red. I could suggest that ordered pair, which is 400 blue and 100 red. Okay, any of those will work. So that's example number 2. If you're struggling, please come up and see me as we do this. Oftentimes it's just a tiny little thing that I can tell you that can set you straight. So give this a try, and then good luck on your quiz.